Hello, my name is Kevin Warren, and welcome to my talk on Take a Break, Deepfake Audio Detection Using Speech Disfluencies. So, what is deepfake audio? Well, it's the ability to make an audio sample sound like anyone of your choosing, given enough sample data. And this can be very problematic, especially over mediums where you're not face-to-face, such as telephony. Or if someone doctors a video and makes someone say something that they didn't. So how does one go about detecting these fakes? Well, we propose that human speech is highly variant, and it fluctuates as you speak in conversation. So by detecting changes or deviations in these speech patterns, we can differentiate synthetically generated audio from those produced by humans. So what exactly is speech disfluencies? Well, there are things in our conversations that interfere with the ability to be consistent in the way that we speak. These are things such as pauses or elongations of sounds, restarts, things like that. And they come from the brain's need to think and the body's need to breathe as we speak. And these are features that aren't necessarily captured in machine learning models or produced during the encoding process. So, how does human speech and machine learning speech differ? Well, humans don't know what they're going to say. They have to think as they speak. While a machine learning model generates speech off of a given text, it knows all of the speech beforehand as it processes the data. Knowing the text beforehand allows the machine learning model to be more systematic, which can make the audio sound less natural, as it doesn't have the disfluencies that come with human speech. So our work decided to look at how these differ and if we could quantify it. Well, we went about looking at the duration of phonemes, the basic building blocks of human speech. So we looked at how long it took to say different phonemes, and we did this by extracting the durations of different audio of the phonemes from different audio samples throughout 3 different synthetically generated audio models. We used the mac-say command, which is a very generic synthetic audio generator, the WaveNet audio generator, which sounds close to what people hear in Google Assistant or Siri, and then we used a Google supervised model where we looked at much more human-esque sounding audio. And what we found was that there's very little deviation, or much less deviation, or variance in the timing for phoneme sounds in synthetic audio comparatively to human speech. And this is a big tell because we as humans vary the way that we speak. And here we see that synthetically generated audio doesn't have the same variation. This can be a huge tell to differentiate the two samples from one another. If a sample doesn't have a whole lot of variance, you can tell that it wasn't generated by a human. So after the classic mid-presentation interruption, the takeaway to all this is that disfluencies can be used to help differentiate human speakers from synthetic speakers based on the differences in their speech variations. Thank you.